Hello, I hope I'm alive. I just need to check. Where can I see the comments? Can someone comment to see if I am indeed alive? I'm not just talking blah, blah, blah by myself. Anyone on YouTube or... Thank you. Anyone else? On LinkedIn. So I know on YouTube, everything is working. Yeah, fantastic. So welcome to this session. I decided to invent it because I need to buy... Yeah, so David, thank you on LinkedIn. Yeah, so welcome everybody. I decided lastminute.com thing to create this session just to catch up with everyone in the community and maybe just give an overview about the QF Academy, what's currently available right now and what's coming and in the near term, and also what we look for towards the end of the year to have. So let me just, and feel free to type any questions. And yeah, Happy New Year as well. And then, yeah, I will just open it up. You can ask any questions, whether to do with the QF Academy or any other thing that you might want to ask. We are here for that. Just as a curiosity, I'm curious to know where everyone is dialing up from. Can you just... I know we are a global community, so we have community members across the world. I'm actually in Brazil at the moment, so I'm joining in from Brazil. Yeah. Yeah, I know. David, I believe you are from South Africa. Okay, so maybe just I will just start with an overview of what we have right now available in terms of courses. So at the moment, we have, maybe change this setting, this layout. I don't know if you can see. Maybe this way is better. Can everyone see the screen? I mean the overlay. Yeah, so we have people from Midwest US as well. I think, as you can see, I'm new to this platform. Maybe I'll do this background. Yeah, we have... Yeah, David has confirmed he's dialing in from South Africa, Johannesburg. Cool. Okay, yeah, so sorry for that, for anything with this overlay thing. I'm trying to get this thing, the background at least. Yeah, anyway, I think you can see. Can anyone see the thing displayed, the overlay? It should be on thing on top of me. At least that's how I see it from here. Maybe I should try to do this. Let's see. Yes, it is fine. Okay, thank you. Thank you, David. So right now, these are the available courses. I'll walk you through with each of them. With each of them, the first one is writing and understanding proofs. So this is a foundational. So thank you for the feedback. One of the feedbacks that we got from you guys is that it was confusing to know which courses are foundational, which one are a specialization. So find the foundational courses. So now we have labeled them. So foundational level courses are like not really beginners because as you know, in quantum formalism, because of the nature. Yeah, so thank you, George, for confirming about the overlay. Yeah, it's probably weird. You can see me also, part of myself on the thing. I'm trying to get rid of it, but I don't seem to be able to. Yeah. So anyway, you can see the image. Yeah. So foundational level courses are intro level courses. They are beginner friendly, beginners in the sense of quantum formalism. So meaning that for you to be able to take our courses, even the beginner, the foundational level courses, the ideal background for you is to have taken university level mathematics, undergrad at least. Because we focus a lot on structural, abstract structural things, mathematical structures. If you have you have never taken university level mathematics, you will most likely struggle unless you have self-taught yourself, some of the basic stuff. This is because university level, say for example, you are taking undergrad degree in engineering or computer science, you learn linear algebra, right? But you learn it more in the computational aspect of it, learn how to multiply matrices, and know a bit about some properties of matrices and these things. For example, that for example, let's take n by n matrices, like square matrices. That they don't commute, meaning that if you have two matrices A, B, A times B is not necessarily the same as B times A. Okay, this is something that you learn. But what you probably didn't learn if you are taking computer science or engineering degree, even though you know this, is that there is a very rich structure in these matrices. For example, they form a ring. In this case, a non-commutative ring. Or we could go even more to say they can form an algebra or even an R module. So you are not aware of this, but because you're already being exposed, to the basics of it, you know how to operate, to perform operations on them. It makes it easier for you. Then later, if we introduce you the abstraction, the abstract structure, say of a ring, then it's easy for you to digest. Likewise, that some matrices are invertible, not all of them. And the ones that are invertible, they form a group structure. And this is not something that has been, people generally working for in the applied stuff. They focus too much on the thing, on the group, on structural things, So that's why I'm saying, or we've been saying, you do need ideally to take our courses to have taken university level mathematics. So that way, the abstraction, when you get hit with abstractions, things become easier for you to observe. You will probably be familiar with certain property of things. It's just, you are not aware, of how these things are organized. So it makes it easier for you. Okay. So foundational type of courses in QF are introductory. But as I said, the baseline is that you would have already like some university level mathematics, even though they are beginner friendly. It's not a beginner for someone who is never being like exposed to university level maths. Specialization are a little bit more advanced, and they tend to focus on use case, on specific applications, but also they deploy a little bit more rigorous in terms of like proof writing and this type of stuff. The emphasis is given a lot on that as well. So these are the two type of courses that we have: foundational and specialization. So right now we have writing and understanding proofs. there is a free version of this on our YouTube channel. Max, my colleague, was kind to provide like live lectures where people could ask questions. What we did was to create another version, self-paced, with the questions, quizzes, and these things for people to test their knowledge. It contains all the basic proof writing techniques that you will definitely need to understand, because a lot of the proofs that you will learn later in the more advanced courses will be using these proof techniques, and sometimes you use more than one proof techniques, so it is important to be familiar with them. The other one is advanced linear algebra for machine learning. This is actually a hybrid course, meaning that there is a self-paced element to it, but at the same time there is a live tutorial. So basically, what based on the feedback from those who have registered, we are releasing video lectures, one lecture at a time, ahead, like 1 week ahead, say, for example, on Sunday, and then people together with problem sheets and quizzes and these things. So the idea is that you will, the learners will audit it ahead of time on their own pace, and then on Saturdays we have the live sessions for them to join the instructor for live tutorials and also try to solve the problems, because mathematics is similar to any other disciplines like sports. You need to practice. If you don't practice, you will not get build up your fitness. So you do need to practice. And these live sessions are made to encourage people to come up and bring their own to test out their own knowledge, and where users agree, we record the sessions, but we have the possibility also, if someone doesn't want to show up, on the recording sessions for the others to see, we can just stop, and then the person shows up on the screen to try to solve whatever, and then we start recording if the next person is comfortable with the recording. Yeah, so it's not compulsory that the live tutorials are recorded. It's depends on the consensus. Yeah, but we do encourage recording them so you can replay. First of all, because this is not available on a thing openly, so it's only available to the cohort. I think it makes it a little bit more friendlier, so you don't have to feel like embarrassed and held back, from making mistakes. Yeah, in fact, making mistakes is part of learning, right? If you don't make mistakes, you will not learn, right? So we do encourage people to come on stage during the live tutorials to try to solve the problem before the instructor walk them through the solution. So this is an experiment, this advanced linear algebra for machine learning in terms of the format. So it's self-paced, hybrid in the sense of being self-paced, but also with live session. This is something that we want to do with the Lee groups with applications. Having spoken to the early signups, it seems like it's a format that most people are keen to follow, to deliver. So yeah. The other course, this one is pure self-paced, mathematical foundations for quantum computing. So the module 1 of this, which consists of the basic stuff about Hilbert spaces, in this case finite. We are focused on finite dimensional complex Hilbert spaces. It's available for auditing. So the second module of this course will be available at some point early next year as well, in January, just in a few weeks' time, with emphasis on the operators and like the unitary operator, the special unitary operator, these things that show up in quantum computing, because the quantum gates, they have these structures. So, and also there will be like some use cases in quantum computing. So this course is available for auditing, so you can start auditing it right now. The other one is this one on Lee groups with applications to machine learning and quantum computing. So the prerequisites, let's see if I can find the prerequisites. Just give me a second. I don't think in the meantime, please feel free to, if you have any question while I'm looking for the prerequisite. Just a moment. I must say, unlike Zoom, unfortunately, I cannot just invite people on stage. So you would have to tell me before so I can share the thing with you. So you do have to type if you have any questions. You have to type on the screen, on the thing, on the chat, please. Let's see. Prerequisite. And people who sign up will have access to this prerequisite. Let me download. Should have done this earlier. Am I still on, by the way? Because I don't see any activity on the chat. Let me just stop this overlay for a second. Yes, so I'm still on. Let's see if I can present slides. It should show up in a minute. Anyone has any questions so far? And then I will open up to broader questions. You can ask everything. I'm just going through. Yeah. Can you see properly the, let's see if I can zoom this. Can you see something loading? Let's see. Yeah, so I have a question. Could you write a summary of dates when courses begin and Saturday live sessions? Yes, we will be updating the syllabus. Actually, you can upload it, download it from the courses website. So if you go to the landing page for the course, it will be available there over the coming days once we have actually the fixed date and also agree, because at the moment we are onboarding the early signups, so we need to send out a survey to decide whether they want to do live session on Saturday. The Saturday thing was an example of the machine learning, the course on machine learning. The Lee groups one, we don't know whether people taking the Lee groups, maybe they might want another date. They might want Sunday or Friday. So we will be sending a survey on that. Now, if you are asking whether, if your question is related, George, if this question is related to the advanced linear algebra for machine learning course, then yes, it's on Saturdays and the sessions are held at 2 p.m. GMT time. I think this will be like in the morning time for you. For the one on the course, the Lee groups and course, we still to determine which date the live sessions will be and what times. So this will be depending on the survey we send out to the early signups, to people who sign up to the course, so we can take like a lazy majority view. You know, we will go with what the majority feels more, or try to find a middle ground. Okay, so George is saying he sees the border. Just hang on a second. There was another second question. Are you planning on using any particular test books for Lee groups? Yeah, we have some references that we will be putting out on the thing, on the platform for you to go and audit, but we won't particularly follow exactly like, just follow the structure of the test book, not at least because, test books normally, especially the ones that we have in mind related to pure mathematics, mathematics is their main thing. So in here, we are focused on the application. So we don't necessarily follow the same thing because we have to tailor the mathematics to the application. Yeah. So we will be doing some recommendations on test books, but we won't necessarily follow the same format. We'll have our own thing based on the specific outcomes that we want. So there's another question before I see test with border force. Yeah, okay. So, but can you see the content of the test, which should be the syllabus? Let's see, what can I do here? Okay, maybe I might have to do this in the hacky way. Just a moment. Done. Just give me a second. Yeah, I like this new platform thing that we got for these community sessions, but I'm actually struggling a bit because it does have too many widgets, too many, the menus are too much, too many options and these things. And sometimes they have the icons. It doesn't say what the thing is. Topology. All right, so what I will do, I'll stop. And then I will add another overlay. So fingers crossed that you can see this. Okay, can you see this now? Is it better? So you should see a thing, an overlay, topology and manifolds. It's actually nice because it covers my, I'll try to not move my hands so you don't see. Is that a yes? You can see the overlay on topology and manifolds on screen. Yes, okay, thank you. Thank you, Learning. Yeah. And Michael as well, thank you. Yeah, so this will be the prerequisite for the Lee groups with the applications. So you do need to know, I think the were in the email you that sent out. Yes, they were, but there's, thank you, David, for that. I'm just going through this again because there might be some people who are just joining through LinkedIn or YouTube that haven't seen the email. Yeah, but thank you. Yeah. So, yeah, test is clear now. Thank you, George. Yeah, so Lee groups, because of their nature, even though there is an emphasis on groups and groups are algebraic structures, Lie groups are actually more, they're not just algebraic. They have topological, they have geometric, rich geometric structure. So there is an interplay between these fields, the algebra and geometry, in this case differential geometry. So you do need to know not just the algebra, the group theory stuff, but also the topology and manifolds. And it seems like most people who have signed up for the course, they have taken like linear algebra, which is also a prerequisite as well. I still only see the course list. Is it? Let's see. How about now, David? Yeah, so this is exactly, so George, this is exactly, so I see topics 1, 3, and the first line of, okay. Let's see if I can do something with the layout. I'm changing different layouts to see whether you can see better. Is it better now? Can you see the 4 items? So this is basically the prerequisite that we will be doing: session 1, session 2, session 3, and session 4. And each of the sessions have specific items. For example, session 1, which will be introduction to topology, you will go through the fundamentals of topology, like understand what open sets and closed sets are, continuous functions, these type of things, And luckily for some of you who have been taking my free course called Abstract Mathematics 101, we've been covering topology for a couple of weeks now. And in fact, we started with point set topology, and now we are on metric topology section, meaning that the topology induced by the metric space structure. And soon, we will be jumping into manifold section. Yeah. Okay, so it seems like I'm really sorry about this. Some people are not seeing the prerequisites, so maybe I will just speak over. It's probably better. So we will have introduction to topology and manifolds in the Lie groups course. So there will be a prerequisites things for us to do. This was a prerequisite, but because most of the people who have signed up. Okay, so Michael, it seems like there is it might have to do with the screen resolution that you guys are on, because Michael seems to be able to see everything. But I'm sorry anyway for the thing. But I'll come back. I'll come back to just going through, spelling it out myself. So we will have a prerequisite on topology and manifolds before the actual course. And we will start with the first session, Introduction to Topology, where you will learn the basics of topology. The second section's foundations of smooth manifolds. So you will learn a bit about the manifold structure. And then the third session will focus on stuff like tangent spaces and smooth maps. And then the fourth session will be like some sort of a prequel to the actual course on Lie groups. So it will be to try to bridge the materials from topology and smooth manifolds to connect them with the Lie stuff that you will be learning. So yeah, so this will be. There will also be a prerequisite on group theory as well, because some people are not that comfortable with the group theory as well. So there will be a review on group theory. Let me just see. I will share the syllabus of this. Hopefully this is better. And then I will take all your questions. I see some questions there on the thing on the side. On the chat, I mean. If you have to leave, don't worry. You can come back to rewatch this. I will be able to answer your questions. You will see me. You will hear me answer your question. Let's see. Group theory. As you can see, this session wasn't planned, so that's why everything, because I only decided to have this live session today. So you can see it's not, it was improvised. So therefore, nothing was ready really. It's just to set up the thing. Because my intention was just to open up for like Q&A, and I will do that in a minute. Okay. Yeah. Okay. Can you see the second overlay on group theory? Yeah. Sorry, George, for the awful experience on the thing. It might be because you are George. It might be because you are. I can see on the icon you are joining from LinkedIn. Maybe try to join from YouTube to see whether your user experience gets any better. Okay, so can Michael, I guess I will rely on Michael. Yeah, so fantastic. Yeah, thank you. Yeah, so we will have a prerequisite also on groups. Some people already seen, the definition of groups. They have seen examples of groups. For example, I was mentioning before this thing of linear algebra. One of the reasons we ask people to have at least baseline university level mathematics before taking our courses. For example, those who have taken linear algebra, say for example, people who have taken courses on quantum computing, and they learn about the unitary groups. Maybe they don't learn about the group aspect of it. They learn about unitary matrices. They know these matrices, the quantum gates, are invertible. And the reason they are invertible is because they form a group. And this is very important. This is actually one of the important aspects of quantum computation is this group theoretic thing, right? Because this is what makes quantum computation, for example, reversible. Because of the group structure. So understanding the group structure is the underpinning group structure is very important. And this is where also Lie groups come in, because these quantum gates are also Lie groups, okay? Both the unitary and the special unitary group. This is actually one of the things that you will learn from this course. These are like the prototypes, the prime examples of Lie groups that have applications in quantum computing but also in machine learning. So understanding the group structure is very, very important. Whether you are doing quantum machine learning or quantum error correction, all these things, in fact, I actually had something very interesting, because Google recently, they published a course or something on Coursera on quantum error correction, I believe. I haven't really checked it out, but I saw some comments, but it was meant to be for engineers and these things, but it turns out that having mathematical knowledge definitely helps, So, in fact, understanding your group theory and these things, will be very important to understanding a lot of the error correction toolkits, that you learn over there. For example, Pauli groups, are used in some of these things, and the reason why it's called group, because it has group in the thing after Pauli, is because they form a group. So understanding the group structure definitely will help you understand better these things, and the problem with many people face in learning things that don't emphasize on the structural side is they rely a lot on toy examples, on simple examples that give, just to convey the idea. But the problem is very often some toy examples will not give you the general picture. For you to get the general picture, you really need to understand the underpinning mathematics of it. In this case, if the thing that you're learning has some sort of a group theoretic property, okay, it's good to see an example, but then to generalize, you really need to be able to understand the underpinning group theoretic concept behind that. Okay, so the same thing with also, when you add the least the manifold structure try to bring the manifold structure with the group structure. In the case of the Lie groups, then suddenly your whole thing, understanding becomes, much better. So we will have a preview of group theory, covering these baseline topics, the fundamental stuff. Then most people actually, they know the fundamentals, like what a group is, homomorphisms and isomorphisms and this type of stuff. But most people, according to the survey, they actually struggle, or they don't feel confident, or never being exposed to, say, for example, group actions, and representations, which is something you need to understand, at least the basics of it, before we put this thing into the context of Lie groups. So this is it. So this will be all about the Lie groups with application course. So there will be a prerequisite we didn't intend to do initially, because we thought, okay, yeah, people will have this, but it turns out that it's actually better if we do it. So we will be doing it. So therefore, this means actually it opens up opportunity for for people who don't have this prerequisite, to actually join the course as well. So yeah, even if you were not intending to take, Lee group stuff, you were not the thing, but you wanted just the basic stuff, you could start with the, at least having a shortcut with both on the topology and manifold prerequisite section, but also on this group theory stuff. With that, yeah, so George is saying the interface is smoother. Perfect. Yeah. Okay, so let me go back again. I believe I was here. Yeah, so the courses should be back again. So that's it. So this in the near future, in the next few weeks, Lee groups with applications will be available. The other courses before it, like the Mathematical Foundation for Quantum Computing, this is all available there for people. If you are interested if you are interested with Lee groups course, and your goals are quantum computing, it might actually worth revisiting the Mathematical Foundations for Quantum Computing. And anybody who signed up for the Lee course will automatically have access to all of the others in case they want to review. So this is one of the advantages. We are opening up, making it as easier as possible for you to equip you with the prerequisite you need in order to succeed in taking the course. Okay, so the second wave of courses that we are very excited about. Let me go back to the comments just to make sure, because it's important. Can you see the second, can you see the second screen? It should contain something on fully homomorphic encryption and post-quantum cryptography, or abbreviated PQC. Can you see that? Okay, let's see. So someone does not see the overlay. Okay, maybe I will stop and do it. How about now? So the first item should be fully homomorphic encryption and PQC. PQC is standing for post-quantum cryptography. Yeah, so you can see. Okay, so this course is very cool because this will focus on cryptography. In this case, there will be emphasis on fully homomorphic encryption, but also on post-quantum cryptography. The reason we did this is because by default, most existing homomorphic encryption schemes are post-quantum. So when you do homomorphic encryption, these mathematical problems like learning with errors and these things that these homomorphic encryption schemes are based on are thought to be quantum resistant, or at least nobody has so far found any algorithm that breaks them. There was a paper recently, well, not recently, I think it was last year or something, a researcher from China, I believe, published a paper saying that he found an algorithm that basically breaks the learning with the error problem, solves the problem in a reasonable time. Yeah, but it turns out that there was an argument with that. So the problem, still unsolvable. So that means that all the homomorphic encryption schemes that were based on, on the learning with the errors problem are still standing, as far as we know, unless someone has, some hidden algorithm out there that they haven't published. Yeah. So this makes fully homomorphic encryption schemes post-quantum as well, and we will also take this bridge between, the post-quantumness of them to also cover the NIST standards as well, some of the niche standards, so this course will be basically for those who are really interested in cryptography stuff and also in post-quantum cryptography. The second course is on category theory with applications to both quantum computing and also AI. It says in production because we are working on the curriculum still, and we should be in a position to start producing them as soon as possible in the next coming few weeks. And then, once it's almost ready, that's where we open up for early bird sign up for people to prepare, because there will be some prerequisite also with this type of with these courses. These more so as you can see, the specialization courses will always require some sort of a prerequisite, basically. Yeah. The other course, this one I'm really excited about, it is something on operator algebras, in particular with the emphasis on C-star algebras, because they have applications in quantum computing and also in machine learning stuff. And this will provide the foundations for the other one. This is in consideration. As you can see, we are not saying it's in production, but I really think this is very cool. This thing of, providing a course on non-commutative geometry to try to see, whether people, look at some early, because this has been mostly like mathematics and, mathematical physics type of things in terms of applications. Only recently that people start to think about the possible applications of implications of this into other fields. So, and operator algebras in particular, coming from, with emphasis on C-star algebras, will provide you with a shortcut into non-commutative geometry. So we do want to do this, or at least we are very keen into doing this. This is also within our spirit of making abstract mathematical structures accessible, even if nobody has used a specific structure. For us, we will still be very happy and to see the impact if you're being exposed to a very obscure mathematical structure, and you find some you are like the first one to find the application for it in the thing in some of the emerging stuff, whether AI or quantum. So it's definitely something that we are very excited about, and I would say that it's probably going to happen towards the end of the year, because you do need some solid foundations and other stuff, so for non-commutative geometry, you definitely need operator algebra stuff, you need to know that. And this will also provide you with the previous courses, like the Lie groups on the geometry side, and category theory will also provide you with the toolkits you need in order to be able to really explore this topic. So with that, I'll stop sharing this and I will go through some of the questions I've seen, because this is all I have about the Quantum Formalism Academy course, what's coming up, what's already out there that you can start auditing right now. And then we can open up for questions, anything that you want to ask, happy to answer. And if somebody wants to join the stage as well to make any comment, just feel free to type. And if you have my email, you can email me. I will add you at the back, or else you have to type your email here on the chat so I can invite you. So let me stop. If I find how to stop this overlay, and I will go through the questions. Let's see. I've seen one before about the course, obviously. I will go that to Rishi. So Rishi is asking, how to join. Okay, so you basically go to the courses and see which courses. So you go to the URL about the courses, the quantumformalism.academy/courses. And then if you click the links for whatever course that you are interested, if it's ready, then you will be able to see how to sign up through that. Here's a link to the courses. I think it was displayed before on the, So just follow the landing pages for the courses. They will give you instructions. If you have any other question, then feel free to ask. I'll follow up with you. Okay. Okay, so any other questions that we might have? So Michael is asking 4 courses are shown. Is that the case? Yeah, these are the immediate courses, or the courses that are available right now for either auditing or in preparation. Like the Lee group stuff, we are in the like prerequisite stuff phase. So yeah. And I also want to emphasize in here, we are actually, unlike other learning platforms, our main goal is really impact, so we are not looking at crowding the thing with too many courses, because for us, it's not about quantity, it's more about quality and impact, what's more valuable to the community members. And having said that, if you want to suggest any course, that it has to be a course with a mathematical nature. This is the thing, because mathematics is at the center of what we do. So it has to be. So if you have any suggestions of any course that we don't have in anything in the platform listed there, it might be we already have it, in our pipeline, but we haven't published it yet. This is something that we would definitely consider. It has to be of mathematical nature. Yeah. So group theory is often presented in a manner which confuses the group and its action. Yeah, it's true. And yeah, I see that mostly in courses that don't emphasize on the abstractions. They start more in like examples. Yeah, and then people, exactly, this is where when you start to give examples, and these examples confuse the actual essence of the structure itself. In this case, for example, separating the group structure, for example, from its action on an object. Yeah. Okay, so this is interesting, actually. Yeah, let me just, so there's a question about the Lee Group's class competition announcement. Are you referring to the my offer? Let's see if I can share. On like Boxing Day, where I offered 15 places for people who satisfied certain conditions, like liking the post, commenting, but also making mathematically hilarious jokes. Is that what you are referring to? Because I cannot see your name. It just says LinkedIn user. Or are you referring to something else? There will also, something I forgot, there will also be, we will try to get scholarships as well for those, in order to try to make this accessible as possible for those who cannot. Obviously, we cannot provide this for free because one of the problems we have with offering things for free is, anyone can show up, and, it's not clear whether people are actually really interested in these things, whether it means something to them. So, and also obviously there is a cost incurred from us, obviously, we need to cover the cost of the structures, of the infrastructure and all the things. So it's definitely something that we cannot offer for free. But we do understand that some community members might not be in the position to do this. So we will be offering scholarships. Let me actually share something about it, because there will be like conditions attached to the scholarship. So it won't be like a blank access scholarship. Come in and he's logging, go access the course. We really only want people who really are dedicated, and also they have the background in order to take our courses. So let me just share. Okay, so the LinkedIn user was saying, was it about the group class? Yeah, so we will be announcing that early next year. Maybe not a full course, but a lightweight introduction to rings, modules, and algebras. Yeah, sometime between. Yeah. I have hard time with Bourbaki style. Actually, this is just exclusive here from those who have joined, or maybe those who happen to watch this later. We are actually thinking about producing books as well, as way of making the courses that we give accessible. So, for people who like to read and these things. So this is also on the pipeline, but it's not anytime soon. Over the next coming weeks, we are prioritizing first on the normal courses. Yeah. David is saying, yes, it would be nice to know if we have got a position on that. You mentioned on the scholarships and these things. So in terms of the scholarship, we will be, because we need to have an infrastructure, like people to monitor progress and to make sure that the people we give the scholarships to, free access to, are actually auditing. They have time to audit the course, and they are actually dedicated to doing it. As we said in the Q&A session about Quantum Formalism Academy when we announced it, we will require people to have commitment. So it won't be like, oh, I don't have time, I've stopped because I'm busy doing something else. No, we will not accept that. You really have to be committed to actually taking it. If you don't have time, then don't apply for the scholarship. Wait until when you have time to take it, because we really want to, because think about it, we cannot give scholarships to everybody. So if you have been given the opportunity, it means you are taking opportunity for someone else. And if you are not taking the opportunity to audit the materials and go through the things using the privileged access that you have, then I'm sorry that we cannot. It's not fair on the rest. Okay, so David is referring to the Boxing Day offer challenge. Yes, we will. I will definitely honor that for sure. I'll be announcing. In fact, there's some other interesting thing that came up. We decided to come up with top 3 or possibly top 5. We will give access to 15 people anyway. Those who fulfill the conditions will have access, but then we will have this. We'll offer badges to the best jokes. So Michael is asking an interesting question. Maybe I forgot I should have been highlighting your questions. Yeah. So what's the difference between early bird and monthly subscriptions in Xamarin Lee groups? Yeah. So the early, maybe we have to change the language here, but this is the best way that we could. So this early bird sign up, basically you have 2 options. You can buy the access, one-off access to the course. That's it, just the course. Or you can, in terms of in line with our thing of making it accessible, you can subscribe on monthly basis. So that means that you pay monthly and you audit. Obviously, if you stop, if you don't, you can cancel anytime if you don't want to take the course anymore. But if you buy it, in this case, in the early bird, for example, this is a one-off thing, one-off price. You will have live access to the course, basically. Yeah, we should probably make it emphasize this more, make it clear the difference. I hope that answered. If not, I'm happy. Feel free to follow up so I can. Okay, so this is another very good question. How does the Abstract Mathematics Bootcamp, which I'm doing right now, well, we've been doing it since summer, last summer, fits in this? So actually, to answer this, George, just give me, it's a very good question. I need something. Let's see if I can present. What I need is another overlay. Let's see. Because this could provide opportunity. I will be covering Lee groups as well, but it will be not with the applications in mind, but rather just the mathematics, so if you didn't want, if you wanted to save money, or this is not important to you, you can wait until we get there on the thing, on the Abstract Mathematics Bootcamp. That could be the option for some of you. Let's see, Abstract Mathematics lectures, metric topology. Let's see. I'm looking for the course thing. Just a moment. I should find it soon. Lectures LaTeX. Let's see. Yeah, I think this one will do. I could not find the other one, the one that is actually up to date. Can you see this on the screen? Yeah. Yeah, so can you see this on the screen? Michael, I will go to your question in a minute. Thank you. Yes. Okay. So you can see the dates are wrong. I mean, at least this module. So we are still in module 1. It meant to finish on August 30, but obviously we overrun. Because for 2 reasons. One is because of my availability, and the second reason was the class prefer to do it in bi-weekly sessions. So naturally, we are behind time. So we have completed naive set theory and also point set topology. And at the moment, we are in the metric topology section. And then after this, we will go to topological manifolds. So some of the stuff that will be covered in Lie groups, like the manifold section, for example, in here, we'll only cover topological manifolds, definition of a topological manifold, not a smooth manifold, because for that we need to define the smooth structure. This is something that we will do in the second module. So for those who are not in position or they don't have time or something, you could also audit this. Just follow us. Make sure you have the prerequisite, the other things as well, knowledge base, because this is the thing with the mathematics. Everything is built on top of each other. So you can also audit this course. So to answer to George's course, there is synergy between them. Yeah, it's just the Lie groups thing. This course, a lot of things will be, you will actually get exposed to them faster, because the pace, the course it's basically the priority. And in our thing, we are going in a much more slower pace, basically. I don't know if I answered your question, but yeah, there is a synergy between them. And the key difference is that in the abstract maths thing, there's no application in mind, even though I might make references to applications just to encourage, to motivate people. But it will be mostly on pure mathematical thing. I don't know if it answers the question. If not, feel free to follow up again. So yeah, so this is a very good question. So the monthly extends for later courses. So the answer is yes. You can actually, once you start the subscription, you have access to the entire thing. In particular, if you have access to the specialization subscription, you have access to the foundational stuff, but as well the specialization things. Yeah. We are for this Lie. It might be like a confusing. We probably need to clarify what we meant with it, but I guess we thought it was obvious, which is very often a dangerous way of assuming things like that it's obvious to others, when it's obvious to you. So apologies. We'll try to perhaps on the thing clarify this on the page. But basically, the early bird sign up, this is like the one-off price. So you pay, you just have access to the Lie thing. You will have access to the prerequisite as well, everything that you need to the course, and you will have lifetime access to the course. Yeah. Whereas the monthly, then it's more accessible. You're not putting everything in advance, but it's monthly. You are able to pay monthly, and it's just a way of us trying to make it more accessible without being free, basically. Okay, so we see. Any other questions? Okay, so Georgia is making this comment. Well, someone answers my question. Emphasis on abstract maths versus applications. Yeah. Let's see. Any other questions or comments? What you're looking forward to achieving, in the next year? Any New Year resolution or something, or anything to do with the industry, for example? Do you want to make any provision for the industry, whether AI or quantum? How do you see things? What can we expect the industry to achieve, or is it going to be just hype? Will there be any significant breakthroughs happening next year, as opposed to just sensational stuff on the newspaper? Yeah, one thing for sure, I'm very skeptical that we will not have artificial general intelligence next year. We are very far from that. And we will also, I don't think we will have any, achieve any meaningful, development in quantum hardware that enables us to really do the magic stuff, So achieving fault tolerance, for instance, But there are obviously people, questions arguing, do we actually need fault tolerance in order to do something useful? Well, it's an open question. If the claim is yes, then, well, we need to see such a thing. Yeah, so, yeah, this is definitely something that we, in our company, we are also interested, can we, and not just on the computational aspect, because people, for example, in quantum computing, they just think about the benefits, the computational benefits, like the speed up and these things. In our, but then obviously people have been also thinking, to be fair, about, stuff like quantum-inspired algorithms. So these are like classical algorithms that are inspired by the quantum stuff. This is still useful, to that the field is motivating us to create something more practical in the near term. For us, we are also interested in, like, could all this quantum stuff like noise and all these things, the inherent nature of the existing near-term quantum computers help us build better security protocols, for instance. These are all, so it's not just computational benefits, but also are there other type of benefits that we can try? Yeah, so the answer is unknown yet, but I think it's a very interesting endeavor to follow. Too much baby thrown out with whenever the hype cycle hits. Yeah, it's true. Yeah. Yeah, and I mean, you can see that in terms of, it used to be like blockchain experts, and now you have, on LinkedIn, you have all these AI experts as well popping up. So we have here, yeah, thank you, Mike, David. It's really, making it, as I was saying, it's for us, making it. We started this community actually in 2020. Maybe it's a time to actually, I should have given a bit of a background, but it doesn't matter. This is the right time, I guess. We started Quantum Formalism Community in 2020 when we noticed, in the pandemic, obviously people couldn't go out. So they were, the only thing left was to join the meetups. So there were all sorts of meetups, in particular with the quantum computing. There was this, there's still excitement about the field. There are a lot of introductory courses to quantum computing. And one of the things that one noticed was, all of them, or at least most of them, they brush off the maths. They don't want to talk about the Hilbert space structure. They start to, to come up with all sorts of rules and these things that you could actually, if you understand Hilbert space structure, you don't even need to talk about all these other rules that these introductory courses do. So yeah, we realized then the idea was that maybe we can fill the gap on this. We could create courses with emphasis on the mathematical side of things, So we will not brush off the maths, but rather make it come up with a way of exposing this structure in a way that we don't lose the rigor, but at the same time, people get the exposure to the thing, and maybe could go on and do something. And Quantum Formalism Academy is an extension of that for those who really want to take. So that's why we call it career focused initiative program, because it's all about outcomes. We want you to take, when you take our courses or something, the courses will give you a boost, will take you next level, help you go to the next level. That's the thing. And to do that, obviously, we need people who are motivated, who see the value of the courses, and they sign up. And all of you here, most of you are on the thing, you can, I think it's you fit this profile, which is why we are very excited to working with you to see whether we can help you achieve your goals, whether in research or any other things that you want to do. What actually aku perlu? Yeah, so this is, I'm less clear on what actually, yeah, I mean, there's still a long way to go, even though obviously the quantum hardware makers, they're having a tremendous progress, in trying to engineer these things. The engineering features is really like, these are like very, very complicated way of building hardware that they have to go through. And at least also we have different modality as well, and there's also been discussions about which modality, is it superconducting, is it photonics, and these things that will actually scale. So there is also that, it's not clear yet, and for us, actually, we are very excited about this possibility of networking. Quantum networking has been making progress, and this possibility of networking multiple quantum processors together, as opposed to building something big, like a big monolithic system, could actually possibly provide us with a way of getting to useful quantum hardware that could solve problems that we expect a quantum computer to be able to solve. So we are really excited. I'm particularly very keen on distributed algorithms. In this case, distributed quantum computing will, I think, be possibly one of the pathways for us to get to usefulness, I would say. Any other questions that maybe I didn't miss? Let's see. Anyone wants? Yeah, feel free to ask any questions, please. Now is it? Let's see. I'm just scrolling over to see if I've missed anything. Yeah, I think I've answered all of them. Yeah, so this is a good question. Do specialization courses have a community? Yes. So we have a channel. There will be like a forum as well. You can interact, apart from the live sessions that we want to we introduce, like the one going on right now with the linear algebra, which happens on Saturdays. Yeah. And another thing I forgot this is probably something that I should have mentioned on the Lee Groups thing. There will be like notebooks as well, available, because I know a lot of you are coming from like, data and computer science background, so the ability for you guys to have the Jupyter notebooks and go and play around with things, could be very, very useful. So we have a thing from Ibrahim. What will be the most fundamental need to start for the yeah, well, so the course on the mathematical foundation for quantum computing will actually start in a way. It already has the linear algebra component to it, but if you're already being exposed to it, because now you are learning the linear algebra in a more abstract, in a more rigorous fashion than what you learn in a typical engineering degree. For example, in the mathematical foundation for quantum computing, you start with defining what a field is. Actually, no, we don't. We skip that. We just assume the field is either real numbers or the complex numbers. In our case, we are focused on the complex number, and then it starts with defining what a vector space is. Definition of a vector space in an abstract sense. Most engineering courses, if you look at them, they start, especially physics-oriented, engineering-oriented stuff, they start to tell you about vectors is something with direction, with magnitude, blah, 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 and these things. No. You need to view it. That's okay for like, visualizing things in like, with the applications in physics, for example. But for you really to be able to master these things, you need to think about vectors in a more abstract manners. Okay, not the least because a lot of these examples they can give you like example with the three-dimensional Euclidean space. That's okay, you can visualize things and these things. But what if you go to higher dimensions? How can you visualize it? Or in the case of quantum computing, actually. In quantum mechanics, infinite dimensional Hilbert spaces are the ones that people deal with. So, these have like infinite dimensions, so you don't really. In fact, we had a video, a meme video. I don't know if you saw that on our channel with Lex Friedman. So we decided to use an interview that he did some time ago about, what is a Hilbert space, and then we have these cats telling the thing, trying to explain what a Hilbert space is. Yeah. So Ibrahim, anyway, to going back to your question, if you already know some basic linear algebra, which if you are coming from an applied topic, it will probably be real linear algebra based on Rn, real numbers and these things. Whereas in this course, you'll focus on complex vector spaces, in this case, Hilbert spaces. George, let's see, is real? Yeah, so it will be mostly for classical machine learning, the application. So the focus will mostly be on real vector spaces. But a lot of things are actually overlap. Yeah. So. But the mathematical foundations of quantum computing has the complex thing. Lose signal. Have I lost the signal? Someone is hinting. And another resource that I will share with you guys, let's see, share screen. You can go to our YouTube channel. You can see the instructors, there is a series we call Meet the Structures. And also there will be some previews of some courses. Let's see if I can share screen. Just give me a second. Quantum formalism. Yeah, so let's see. Yeah, so I don't know if you can see the screen. Let's see how I can make this. Yeah, so if you go to the Quantum Formalism YouTube channel, this is a new YouTube channel dedicated to just quantum formalism. You can see this. This is his Lex Friedman thing I was saying about his interview with Sean Carroll when he's asking what is a Hilbert space and the Euclidean space. Nothing is frozen for me. Yeah. Okay, so yeah, so you can access, like some previews. There will be some previews of some of the courses. Like here, obviously, that has ads because this is public. Yeah, but yeah, you can follow us and meet the instructors as well. The mathematicians that will be doing this thing. So you have everything really to just get to know more about what we are trying to do, and see whether this fits with what you want to accomplish. So, and one of the things that we really aim at over the coming thing is this thing really on exposing and like different lenses, different mathematical lenses, to people, because very often this could help unlock something, create new opportunities, when people are getting exposed to different one object, in a different with the different mathematical lenses, because a lot of these things sometimes, the different branches of mathematics, the power is actually in their interplay, the ability to be able to leverage the intersection with the different branches of mathematics. So this is something that we will emphasize a lot in our course structures. But it will start with obviously what we are starting with at the moment, the stuff to be more focused and also give people the baseline thing. So then when we go to the next level, even a more higher level, we're already in the higher level, but we want to always go up with you guys, with the community members. So yeah, if you don't have any questions or any comments, and then maybe we can end it here. As I said, this was improvised. I wasn't planning to do this, but I was like, I need to. It's actually a great opportunity to catch up with people, and just to wrap up and yeah, and share some ideas and listen also with the feedback from some of the community members. How they see these things and what else can we do. Okay. Anyone else before we go? Should I end the stream? Anyone wants to make any comment or something, or ask any question? Will you go into holography at some point? I don't actually understand holography. Well, if there is a mathematics, if I'm not sure if you are mentioning this is to do with string theory or something, definitely. This is something, I mean, we will focus mostly on things that have applications, not just right now, but things that can boost existing stuff from the application sides, but there will be opportunity, obviously, to cover things that are more of a researchy at the border of the science fiction or something, if you know what I mean. So okay, so it's to do with the lasers and these things. Yeah. Well, this is physics and these things. I'm not sure, but maybe this is something that we can look at to see, is there any interesting mathematics? Yeah. So it's he's saying it's a step above photonics. Yeah. We can definitely look at that, but I suppose this is an area where quantum mechanics definitely will probably play a role. And then the question is how sophisticated you want to go into quantum mechanics itself in order to understand these physical systems, the properties that underpin them. So especially new things. If you want to discover new things, yeah. So this is definitely something that we will be looking at, and that's why we will open up, like, people suggest courses that they want, as long as it's not like, I would say, like, toy courses, like, I don't know, calculus and this type of stuff. This is like too boring, let's say. I know it's useful in these things. We want you to be exposed much more sophisticated and interested in mathematics, basically. So anytime with that, we are very open armed to help you with, to try to create something. The rest, all these things about calculus and all these, you can, there are a lot of good resources already out there that you can pick on, and they're actually not exciting, this thing. It is important, by the way. I'm not dashing calculus. It's very important, but myself and the instructors, they are not really excited in teaching it, because it's like, it's good to know, because you learn, for example, in Lie group stuff. It's very nice to know, because you will basically be doing calculus on manifolds, but the subject itself, as it is done, like at the undergrad level, is like, it's how many years calculus has? I think this thing has been invented, what, Leibniz? Is it Newton? And I don't even remember. I think it's probably 15th or 16th century. We want to basically, to sum up, what we would like is to bring you into the modern mathematics. This is one of the thing that we want to do. Yeah. Also, thank you, George. So calculus was invented in 1600s. Yeah. Yeah, I think so too. It rings a bell. Yeah. Now we want you, instead of creating courses around something that has been invented in 1600s, what is more interesting to us is to expose you to mathematics that has been invented, say, like, maybe 20 years ago, or actually, let's not be that ambitious, maybe 50 years ago. That's a good thing, because mathematics that has been invented 50 years ago is still not very accessible to a lot of people. Take, for example, algebraic topology, for example, or even category theory. So these are the things that we are more excited about. Yeah, close to 500 years. Yeah. So there's a huge body of knowledge with calculus. Yeah. I was actually talking to a machine learning person. I was like, man, you guys, you boast about gradient descents and all these things, that uses mathematics that's like 500 years old. You need to modernize your thing. Come up closer to modern mathematics. Yeah. Okay. So, any other comment? Modern mathematics versus old mathematics. It's actually surprising me that people still think machine learning is hard because of something that has been invented 500 years ago. No. Okay, I'll give 1 minute, and if not, we can end the stream here. And you can go, and I know it's the final day of the year, 2024. I hope it has been very fruitful for all you guys, and I hope you have a great entry to the new year, and let prosperity and your dreams, everything come open up for the entry of the new year for you guys, and for us, we look forward to seeing you again. Yes. Have a peaceful year indeed. We need peace in the world. There's so much tragedy and these things going on. So fingers crossed we have peace across the world, in Europe, in other forgotten countries where there is still unfortunately things happening, in Africa, in Asia, and so on. So yeah. Okay, so with that, maybe I will end the stream. And as most of you already, you can just reach out on LinkedIn or on, just add me on LinkedIn, or message or follow Quantum Formalism if you have any questions. Most of you will looking at the audience here already have my email, so just feel free to reach out anytime, and yeah, I'll do my best to reply as soon as possible. So I see you next year. We have exciting announcements that I cannot, I wasn't allowed to announce, that we will be announcing in the new year. So with that, thank you everyone, for joining, and have a great end of the year. Happy New Year in advance, and we see you on the other side. Thank you. I will end the stream now. And see you.